Non-stoichiometric defects. The ratio of combining elements in the compound is different from that required by the stoichiometric formulae. The defects which disturb the stoichiometry of the compound are called non-stoichiometric compounds. These defects are either due to the presence of excess metal ions or excess non-metal ions. Non-stoichiometric compounds are of two types: metal excess defect, metal deficiency defect. Metal excess defect. The solids with metal excess defect contain metal ions in excess to the stoichiometric ratio. Such defect is caused due to anionic vacancies, excess of extra cations at the interstitial site. Metal excess defects due to anion vacancies. In anionic solid, an anion may be missing from its lattice site, leaving a hole which is occupied by an electron. To maintain the electrical neutrality, the anionic site occupied by an unpaired electron is called F centers, where F stands for Farbencenter, which is a German word for color center. F centers are responsible for the color of the compound. This kind of defect is shown as alkali halides, such as sodium chloride and potassium chloride. Metal excess defect due to the presence of extra cations at interstitial sites. In this type of defect, metal excess is caused by an extra cation occupying the interstitial site. To maintain electrical neutrality, an extra electron is also present in some other interstitial site. This defect is found in crystals having Frenkel defects. Example: zinc oxide is white or colorless solid at room temperature. But when zinc oxide is heated, it loses oxygen and turns yellow color. ZNO gives Zn2 plus 1 by 2 O2 plus 2E minus on heating. The excess Zn plus 2 ion gets trapped into the interstitial sites and the released electrons get trapped in its neighboring interstitial sites and maintain the electrical neutrality. Crystals with either of these metal excess defects contain some free electrons. Hence, such materials are semiconductors. Metal deficiency defect. This kind of metal deficiency defect is created when a metal ion goes missing from its original lattice site. To maintain the charge neutrality, same metal ion having higher positive charge is added to occupy the vacancies created in the crystal. As this metal ion has higher positive charge, it will occupy only some of the sites to balance the overall charge, and other sites will be left vacant. Example: FeO is mainly found having a composition of Fe 0.950. In crystal of FeO, if some of the Fe2 plus ions goes missing, then the loss is compensated by the addition of Fe3 plus ions. In this way, though the overall charge is balanced, some spaces will be left vacant in the crystal.
तो बेटा बात कुछ ऐसी है कि वीडियो पसंद आई हो तो ज़रूर से लाइक शेयर सब्सक्राइब कर देना, बेल आइकन प्रेस कर देना ताकि सारी वीडियो का नोटिफिकेशन मिलता रहे। और यार बटन दबा ही दो, पसंद आई हो या ना आई हो क्या जाता है, एक लाइक शेयर सब्सक्राइब में क्या जाता है, कुछ भी तो नहीं जाता। तो दबा दो, बटन दबा दो, आइंस्टाइन बोल रहा है।